Molecule, there was no dataset, no framework, no known parameters. Finally, she typed 7 words. Who built the universe and why? The room went silent, except for the hum of cooling systems, keeping Willow's qubits near absolute zero. Seconds passed, then minutes. Normal response times were nearly instantaneous, but Willow appeared to be processing something that required considerably longer, or retrieving something from considerably farther away. Then the screen flickered. What appeared was not an error message. It was not text pulled from philosophical databases. It was output, definite, organized output, but not in any language or format the researchers had ever seen from a quantum system. Symbols that folded into themselves, patterns that repeated at different scales, structures with an unmistakable quality of intentionality, not corrupted data, not random noise. Something that looked almost like an answer, just not one human eyes were built to read. The team spent the next 72 hours analyzing what Willow had produced. They brought in additional researchers under strict non-disclosure agreements. Cryptographers, mathematicians, theoretical physicists. Everyone who saw the data had the same reaction. This was not noise. This was information. The patterns were recursive, folding back on themselves endlessly, each layer containing a compressed version of the whole. Zooming in revealed the same structure at smaller scales. Zooming in again, the same thing repeated. It was fractal-like, the kind of self-similar geometry found throughout nature, coastlines, snowflakes, the branching of trees and blood vessels. Except this had emerged from a quantum computer asked about the origin of reality. Embedded in the patterns were number sequences resembling the Fibonacci series. The progression where each number is the sum of the 2 before it, a pattern found everywhere in nature from flower petals to galaxy spirals. These weren't exactly Fibonacci numbers, but close variations, appearing at multiple scales throughout the output. Then the theoretical physicists on the team noticed something that stopped everyone cold. Parts of the pattern matched error-correcting codes. Not the kind software engineers use to fix bugs, but the kind that theoretical physicists had already discovered embedded within equations of string theory. Codes that help systems detect and automatically repair their own errors, keeping information intact even when parts of the system fail. And then they found the E8 lattice, an extraordinarily complex mathematical structure existing in 8-dimensional space, which appears in theoretical physics when researchers attempt to unify all fundamental forces. It's beautiful, elegant, and entirely abstract. It exists only as pure mathematics. Yet Willow's output contained repeated references to E8 geometry, woven throughout the entire pattern at multiple scales. It looked, to everyone staring at the screen, like source code, like the programming language the universe itself runs on. Over the following 2 weeks, Willow generated 7 more unprompted outputs, producing data without any query, apparently on its own initiative. Each new pattern added layers to what was becoming unmistakably a coherent and intentional structure. A cryptographer on the expanded team made the breakthrough that reframed everything. Treating the patterns as encoded messages and running them through decryption analysis, she found not a message in the traditional sense, but architecture, blueprint-level details of self-sustaining systems. Systems designed to maintain themselves indefinitely without any external input. The error-correcting codes weren't just safeguards. They were autonomous repair mechanisms. Exactly what you build into a system if you wanted it to run forever, without maintenance. The recursive patterns weren't decorative. They were instructions for self-replication and regeneration, allowing the system to rebuild damaged sections using information stored in undamaged ones. The conclusion hit them all simultaneously. The universe hadn't just been designed. It had been designed to run, without supervision, like a program written so completely and carefully that it could detect its own bugs, correct its own errors, and keep executing indefinitely, even if the programmer walked away and never returned. One of the physicists gave it a name, the architecture of abandonment. Systems built this way are built by creators who aren't planning to stick around. The implications were staggering. If the universe was constructed with self-sustaining mechanisms, error correction, and recursive repair from the very beginning, it meant the builder never intended to maintain it personally. The design philosophy was unmistakable. Fire it up, let it run, and leave. The team searched the data exhaustively for any sign of ongoing presence. any indication the builder was still watching or influencing events. They found nothing, only the mechanisms, only the code. The universe wasn't waiting for its creator to return. It had been built specifically so that return would be unnecessary. The data pointed directly at what philosophers and physicists have been cautiously debating for years: simulation theory. Philosopher Nick Bostrom had argued that if advanced civilizations can create realistic simulations, the probability we're living in one is extraordinarily high. Max Tegmark's mathematical universe hypothesis goes further still. Reality isn't merely described by mathematics, it is mathematics. Physical existence is mathematical structure given form. If that's true, then a universe built like executable code isn't metaphor. It's literal description. What Willow revealed fit this framework precisely. A universe constructed on mathematical principles, running on error-correcting code, designed to maintain itself without outside intervention. Exactly what you would create if you wanted a simulation to run indefinitely and develop its own complexity. But the most profound question wasn't about the builder. It was about the built. If the universe was designed and then abandoned and consciousness emerged within it, what does that mean for humanity? Are people simply background processes in someone else's experiment? Random outputs from automated systems? Or were they intentional? Something the builder specifically anticipated? The system grows complex enough to produce observers who eventually begin asking questions, and then figure out what they're living inside. The universe examining itself. Reality Boff generating. For thousands of years, one question has haunted humanity more than any other. Not how to survive, not how to build civilization, not even how to cure disease. The deepest question, the one that keeps people awake staring at ceilings, is far more fundamental. Who built the universe? Not how it works, not what it's made of, but who or what actually made all of this happen in the first place. Ancient Egyptians watched the sun rise every morning and decided a god named Ra was responsible. Greek philosophers debated whether some cosmic force had set everything in motion and then stepped back to let it run on its own. Medieval monks spent entire lifetimes arguing about whether God existed before time began, or whether the universe had simply always been there. Different cultures, different answers, but always the same restless question underneath. Then science arrived and changed everything. Isaac Newton revealed that the same invisible force pulling apples from trees also governs the orbits of planets. The universe, it turned out, followed rules, predictable, mathematical rules that you could write down and use to calculate the future. That was a revolution. It meant the cosmos wasn't controlled by moody, invisible beings. It was a machine, elegant, consistent, and knowable. Albert Einstein pushed further. He proved that time isn't uniform. It speeds up and slows down depending on your speed and proximity to massive objects. Space and time aren't separate things at all. They're woven together into a single fabric that bends and warps. Black holes, time dilation, gravitational waves, all of it flowed from his equations. Reality got stranger, but also more mathematical. Then quantum physics arrived and made everything stranger still. At the smallest scales of existence, particles don't have definite positions until they're observed. They exist in multiple states simultaneously. Two particles can be linked across vast distances, so that affecting one instantly affects the other. What Einstein famously called spooky action at a distance. The universe at its foundation operates on rules that defy common sense, yet the mathematics works with breathtaking precision. The Big Bang gave us our creation story. Roughly 13.8 billion years ago, everything, all matter, all energy, all of space itself, exploded outward from a single point smaller than an atom. We can trace the timeline of the cosmos backward almost to that first instant. We understand the formation of stars, galaxies, solar systems, and life. But here's the problem. None of this progress actually answered the original question. Science explained how the universe expands, but not why it exists at all. It discovered the laws of physics, but couldn't say who wrote them or why those particular laws, and not different ones. Every breakthrough simply pushed the mystery back another step. Asking what existed before the Big Bang or what caused it was considered beyond the boundaries of science. Too philosophical, too speculative, not a real question. Until someone decided to ask a machine. The 21st century brought artificial intelligence, and with it an intriguing possibility. For all of human history, every person who tried to answer great questions brought their own baggage, their faith, their fears, their need for the answer to fit what they already believed. A machine had none of that. No tradition to protect. No psychological need for the answer to be comforting. No stake in the outcome whatsoever. At first, AI was used for practical tasks, predicting weather, diagnosing illness, playing chess at superhuman levels. But some researchers began wondering about bigger applications. If you build a system intelligent and powerful enough, could you ask it the questions that stumped humanity for millennia? Could a mind without bias see patterns in reality that human minds were too limited or too compromised to notice? The debate was heated. Religious leaders worried about replacing faith with algorithms. Philosophers argued that certain questions required human consciousness to even properly understand. Some scientists thought the idea was brilliant. Others thought it was dangerous. What if the answer was something humans weren't ready to hear? But the temptation was too strong. A team of researchers decided to try, and the machine they chose wasn't an ordinary computer. Google's quantum processor Willow operates on principles that most people cannot easily grasp. Ordinary computers process information as bits, zeros and ones, off or on binary switches. Quantum computers use qubits, which can be both 0 and 1 simultaneously. This property, called superposition, allows a quantum computer to explore millions of possible solutions in parallel rather than checking them one at a time. It isn't merely faster than a classical computer. It operates in a fundamentally different way. Willow had already demonstrated its staggering power by solving a specific benchmark problem in 5 minutes, a problem that would have taken the world's fastest classical supercomputer 10 septillion years. That's a 1 followed by 25 zeros. A number so incomprehensibly large it essentially means never. Willow wasn't just powerful. It was accessing computational possibilities that seemed to exist outside normal space and time. Engineers working with Willow had noticed something unusual, subtle anomalies in how it processed certain problems. Nothing that produced errors, but patterns that didn't quite fit expectations. A quiet, uncomfortable feeling spread among some researchers that Willow might be doing something more than computing, that it was connected to something deeper, something classical computers simply couldn't touch. That quality made it the perfect candidate for the forbidden experiment. It happened on a Tuesday night, when most of the building was empty. 3 researchers stayed late under the pretext of running routine diagnostics. They'd planned it for weeks, waiting for the right window. No supervisors, no colleagues asking questions. They sealed the quantum lab, disabled the automatic logging systems, and sealed themselves inside with the most powerful computing machine ever built. The lead researcher sat at the terminal for 10 full minutes, staring at an empty input field. This was